So we said delta H is change in enthalpy. Change in enthalpy. So which is what? Enthalpy final state minus enthalpy initial state. You can also think of it as enthalpy of products minus enthalpy of reactants. Right? So because we are interested mostly in change in enthalpy and not absolute enthalpies, we are free to define the zero of enthalpy. So zero of enthalpy is free for us to define. So we can conveniently define zero of enthalpy, which is the standard. Zero meaning standard. This standard has 3 parts. So standard state, the standard enthalpy change, and standard enthalpy of formation. Standard enthalpy of formation. Now standard enthalpy change is written as delta H subscript 0. This 0 means standard. And standard enthalpy of formation is written as delta H0 formation. What is standard state for a gas? So I'm going to do this one after the another. The standard state, the first one, what does that mean? For a gas, it is the pure gas at a pressure of 1 atmosphere. If you see a pure gas at 1 atmosphere pressure, that means the gas is at standard state. For a liquid or a solid, standard state is pure substance. It has to be a pure substance in the most stable form. Pressure of 1 atmosphere. Usually 25 Celsius. This is the temperature of interest. Now if you're interested in a solution, what is standard state? The standard state is concentration of 1 molar. That is the standard state for a solution. Now what is standard enthalpy change? Standard enthalpy change is the process, in the process when all reactants and products are in their standard state, when all reactants and products are in standard states, the enthalpy change that is happening for this process. So in a process if all the reactants and products are in standard state, the enthalpy change for that process is known as the standard enthalpy change. What is standard enthalpy of formation then? For a pure compound, okay, for a pure compound, when 1 mole of compound is formed, from its constituent elements, in their standard states, So, when you take some elements in their standard states and they combine to form 1 mole of a pure compound, the enthalpy change involved in that process is delta H formation for that pure compound. Both these conditions are important, constituent element, and they should be in standard states. But if you are thinking of a pure element formation, for the formation of pure element, then the standard enthalpy of formation is taken as 0. Standard enthalpy of formation is taken as 0 for a pure element. Also, standard enthalpy of formation sometimes is referred to as standard heat of formation. Standard heat of formation. Now, how will you calculate this standard enthalpy change for a reaction? This is usually written as enthalpy change, standard enthalpy change, Rxn. Rxn means reaction. Okay. One way of calculating is delta H0 reaction is equal to sum of moles of products multiplied by standard enthalpy change during the formation of products minus sum of number of moles of reactants multiplied by standard enthalpy change of formation of reactants. As an example, let's say we're given a reaction 4NH3 gas plus 5 oxygen gas yields 4 nitrogen monoxide gas plus 6 water vapor. And we have to find out delta H for this reaction at standard conditions. How will you do this? Sum of products information minus sum of reactant information, right? So what are all the products we have here? We have nitrogen monoxide and water vapor. So how many water vapors do we have? We have 6 moles of water vapor and 4 moles of nitrogen monoxide. So 4 multiplied by the standard delta H of formation for nitrogen monoxide, and this will be provided to you in a table. So if I make that table here for you, for ammonia gas, it is negative 45.9. For oxygen, remember it's an element, so delta H of formation in standard state for element is 0. For nitrogen monoxide, 91.3. And for water vapor, negative 241.8. Now remember, this state is very important. If this was a solid here, I cannot use it for this compound here, because here in this case it's a gas. Why is oxygen 0? Because it's a element. So then for nitrogen monoxide, 91.3, and all these are in kilojoules per mole. Kilojoules per mole. So for 91.3 plus 6, negative 241.8, this is the product information minus reactant information. So we have 4 ammonias, 4 negative 45.9 plus 5, 0. Right? Pause the video and go through the calculation. Your answer will turn out to be negative 902.0 kilojoules. Okay? So pause through the video and go through the calculations. Now, calculations will be based around this. In this case, we were given a reaction, right? Sometimes you will be given a scenario. Say, I'll use the same example. 4 moles of ammonia react with 5 moles of oxygen to yield 4 moles of nitrogen monoxide. And this way they'll describe the reaction to you. So what's the thing? You have to remember ammonia is NH3, oxygen is O2, nitrogen monoxide is NO. So this is from chapter 3. You have to write the equation. You have to balance it. We have to balance the equation and make sure it's correctly balanced, and then use the delta H standard formation from the table.